Hi guys, this is Dr. J here, and in this video we are going to talk about a reaction of ethers, which is called acidic cleavage. So, as the name implies, this is a cleavage reaction done done using an acid catalyst. Done using an acid catalyst. In here, the preferred acids that we use in this reaction are going to be acids such as HI or HBr. These are the common acids that we use to do this cleavage reaction. So basically what we do here is that we try to break an ether bond. Okay, we try to break an ether bond and achieve uh, an alkyl halide and an alcohol. Okay, so in this reaction we are trying to break an ether bond. We are trying to break an ether bond, and then we are trying to obtain an alcohol and an alkyl halide. Okay, alkyl halide. So I have a sample reaction right here. Okay, this is a sample reaction. So in here, in this reaction, what we do is we are trying to break the ether bond right here. Okay, using HBr, and for this reaction you might need to reflux the reactants. Okay, you need to reflux the reactants, and then what you get is phenol and bromoethane as products. Phenol and bromoethane as products. So this reaction is an SN2 type reaction. In general, this is an SN2 type reaction. Okay, in general, this is an SN2 type reaction. And what happens is that in SN2 type reactions, you have a nucleophile and a less hindered alkyl group. Okay, you have a strong nucleophile, and then you have a less hindered alkyl group, and then the nucleophile will attack the less hindered alkyl group and a leaving group will leave. Okay, so this is how it happens. I can quickly show you what SN2 mechanism looks like. Okay, so in SN2 you have two things. You have to have a nucleophile. Here is our nucleophile, and then you also need a less hindered carbon. Usually let's take a primary carbon. Okay, a CH2 group, and then X is our leaving group. Okay, and then this could also have an R group. Okay, it could be a hydrogen or any alkyl group. So this is your primary carbon right here. Okay, so this right here is your primary carbon. Okay, so SN2 happens usually on less hindered alkyl groups. Okay, less hindered alkyl groups. So the nucleophile will attack. The attack is the first thing that happens. Okay, so the nucleophile will attack on the less hindered carbon, and the leaving group will leave. So both the attack, let's call it A, and the leaving, let's call it B. Both attack and leaving happens at the same time. Both the attack and leaving happens at the same time, and what you get is a compound with your new nucleophile. Okay, this is what you get. All right, so you will also have your leaving group. All right, so this is SN2 reaction. I hope you remember this lesson from before. All right, and then this acidic cleavage reaction is also a traditional SN2 reaction. So what happens in here is that by using a strong acid, we will protonate the ether oxygen. So your oxygen will have a positive charge and then the nucleophile, which is iodide in this case. Okay, because we used HI, so this is iodide is your nucleophile. Okay, and it will attack the less hindered carbon. This is SN2 reaction, so usually SN2 attacks, or SN2 prefers to go through less hindered pathways, right? So it will attack the less hindered carbon, giving you isopropyl alcohol, which is actually a secondary alcohol. Okay, in here this is a secondary alcohol, but most importantly the alkyl halide that you received is a primary alcohol. Primary alkyl halide. So iodoethane is a primary alkyl halide. Okay, so that is how it happens. So the strong acid will protonate the oxygen on ether, and then the nucleophile, or in this case iodide, will attack the less hindered carbon, giving you a primary alkyl halide. A primary alkyl halide. Let's do another example. Okay, let's do another example. All right, let's do this. So I'm going to have an ether. Let's say it has a phenyl group. CH2, oxygen. Okay, and then this. maybe phenyl group is too dramatic. Let's do something simple. Okay. All right. So this is the ether that you have. Here is your ether. Okay. And then what are the R groups that we have here? So you have a propyl group, and then you also have this group. Okay, so let's call it R1 and R2. Do I have a primary alkyl group? Of course, this R1 is primary. This R1 is primary. So basically the nucleophile prefers to attack the primary alkyl group. Okay, all right. All right, so let's put HBr for this reaction. Let's use HBr. Okay, it will basically protonate the oxygen. Okay, so basically what you get is a protonation. Let me redraw this so that I don't have to mess with the starting material. Okay, so it will protonate the oxygen, giving a positive charge onto oxygen, and then here comes the bromide, okay, which is the nucleophile, and it will attack the less hindered carbon, giving you excuse me, giving you a primary alkyl bromide. This is primary. Okay, and then the other compound that you are going to get is actually a secondary alcohol. Okay, this is your alcohol. Okay, so this is the product that we can expect. Are we good? All right. Okay, these are the two products that we get. So basically, once again, the take-home message is when you have two R groups, the this reaction tends to go through SN2 mechanism. So therefore, the nucleophile, which is the bromide in this case, tend to attack the less hindered alkyl group. Okay, which is the one that I have identified right here. All right, let's do another worked example. Okay, so now it seems like this is a very easy reaction to understand, right? So let's see if you could do this worked example. I want you to pause the video now and then see if you could do this question. Okay, then I want to see if you could do it by yourself without me explaining it. All right, so what we have here is an ether, okay, and we are putting HBr, so we are expecting an acidic cleavage. Okay, perfect. And then let's identify the two R groups. We have one R group right here. Here is the other R group. Okay, so this is a primary alkyl group. This is a tertiary R group. Okay, all right, so far so good. But here's the thing, when you are putting HBr, we expect HBr to protonate the oxygen, right? So we expect HBr to protonate the oxygen so that you will have a positive charge on oxygen. And then here's the deal. We know that our medium has a bromide as the nucleophile, but since you have a tertiary alkyl group here, okay, and also methanol is a good leaving group. So because of those reasons, okay, rather than waiting for the nucleophile to attack on the methyl group rather than waiting for this nucleophile to attack on the methyl group, something different can happen. This reaction could go through a different way. Okay, so the bond between the tertiary alkyl group and oxygen could break onto oxygen. That is a very very good possibility. Okay, so this bond could break onto oxygen, giving you what? Giving you methanol, which is a very stable alcohol. And then you also get a tertiary carbocation, which is also stable. This reaction happens this way because of the stability of tertiary carbocations. Okay, this is a tertiary carbocation which is very stable. And then the bromide could attack the tertiary carbocation. Okay, giving you what? This is actually SN1 now because the leaving group left first and then the nucleophile attacks after that. It is like, before exchanging your partner, in this case, before exchanging the leaving group to the bromide, you basically get the divorce first and then remarry. So that is basically what SN1 is, right? This will give you a tertiary alkyl halide. This will give you a tertiary alkyl halide. Okay, this is the tertiary alkyl halide. This is a very unique situation as compared to what I discussed before. Why? Because you had a tertiary alkyl group in your ether. Okay, so if you have a tertiary alkyl group in your ether, you have to be careful. It might not go through SN2. Okay, it might not go through the traditional SN2. Instead, it might go through SN1 or even E1. Okay, even this could go through E1. Okay, this could go through E1. Why? Because you have the carbocation and a good nucleophile, so this could easily go through E1. Okay, so so this is a clear difference as compared to what we learned before. Okay, what we learned before. So here's the technical solution. You can read through it by pausing the video if you want to. But basically, when you have a tertiary R group, okay, the cleavage reaction could go through SN1 or E1, okay, giving you a tertiary alkyl halide. Okay, giving you a tertiary alkyl halide. This is a tertiary alkyl halide, of course. And then here is a primary alcohol. Or if it goes through E1, you can get an alkene. You can easily get an alkene. Okay, so if it goes through SN1, you will get a tertiary alkyl halide and alcohol. Or if it goes through E1, you will get an alkene. So with that, I'm going to conclude this lesson. Okay, I hope that you guys understood this reaction. So if you want, you can go back and listen to the video again. Let me know if you have any questions. Okay, have a good one, guys.